Hi guys, we're working on dilation, and yesterday's work or Monday's work, whatever, we started dilating on a coordinate plane. And looking at the board, you just working on your scale factor, as in whatever your scale factor is, you're going to take that and multiply it by the number that was given, by the figure's height. Then we had to convert that, or you had to measure the taco or the triangle, whatever it was. Okay, so there's multiple skills that you guys worked on with the scale factor and how to multiply that when given a certain figure. Okay, you had a lot of different examples. Well, we're gearing up to put this on a coordinate plane, because when we started dilations, just like all our other transformations, we went from space to a square grid to a coordinate plane. And so now we're at a coordinate plane. And when we dilate, we're taking that scale factor and multiplying it by everything. Because if not, we get a bobblehead. And I know I've kind of been mentioning bobbleheads here and there, but today's where you're really going to start to see it. Because when you dilate on a coordinate plane, if you don't dilate the whole figure, whether you grow it or shrink it, enlarging or reducing it, you're going to get a figure that's kind of looks like weird things, because maybe some sides grew and some sides didn't, kind of like a bobblehead. Obviously, it shrunk the body and blew up the head. Okay, so we don't want that to happen. And so when we dilate a coordinate, we have to dilate the x and the y. So your scale factor gets multiplied by x and y, or else you create this bobblehead, which, we can make one. In class, we might have to. Okay, so notes, you should be in your composition book right now. If not, get it out, hit pause. That's the great thing about these videos. If I'm going too fast, just hit pause. If you didn't catch what I said, hit pause and rewind. So here we go. Top of your composition book, the next page, go dilations, just coordinates. Okay, so we're just kind of doing a little bit more and more each day before we actually put it on a coordinate plane, because today we're going to practice what the work is like, and then tomorrow we're going to actually put it on a coordinate plane. So here we go. When you have a coordinate, x, y, doesn't matter what it is, and you're going to dilate that coordinate, you're going to multiply x and y times k. So it becomes k times x and k times y. So you got to multiply both x and y. Okay? That's what it's going to look like. So you're going to take the scale factor k, multiply it by x and y. So this is what we got to remember today. Blue bubble. Remember, when scale factors are greater than 1, you get an enlargement. When scale factor is 1, we talked about in class how it's a waste of time, because it stays the same. And then when we're going to shrink something, remember, we don't get 0 or negative scale factors, because that would be weird and people would be turned inside out and it'd end up in the upside down, which is just weird, because we don't know what that would look like. So when we have a scale factor that's less than 1, greater than 0, we are shrinking it, which is a reduction. So here we go. At the core of a dilation is changing the distance from the center of dilation to the figure. We're either making it larger or making it smaller. That still stays the same on a coordinate plane. You can use this guy, or you can just multiply each coordinate, and that's what we're going to do today. At any point in time during dilations, if you don't like the second way of doing it, you can always revert back to this guy. Okay? You just have to make sure that your measurements are as accurate as possible. So here we go. We're going to just dilate a point, which we're not making the point bigger, we're making the distance from the center of dilation larger. Dilate with given scale factor. This W with the slash means width. That's just a shortcut. I guess it's an older people's shortcut, which is weird because I'm like 35, but anyways. Here we go. So you have a point. Let's just go. I will start with this coordinate and with this scale factor. Whatever. So we're going to dilate the coordinate 6, 7. I did that. I went there. With a scale factor of 2, which means this is going to get twice as far from the center of dilation. Okay, the distance is going to be twice as big. We're doubling the distance from the center of dilation. And so we're just going to do the new coordinates, the prime coordinates as you can call it. That's all we're going to do today. So we're going to take our coordinate and multiply each coordinate by by k. So you have 2 times 6 and then 2 times 7. Okay? And then you end up with 12, 14. That's our prime coordinate. And that's it. If you don't multiply both of them, you get this bobblehead. You blew up something and not the other parts. So it'd be kind of like if you had a scale factor of 2 and I just doubled your height, right? Your height increased, but if you didn't double your, let's say your arms, then you have these itty bitty little T-Rex arms, and that would just look weird. Okay? So everything, meaning x and y, has to increase by the scale factor. That's all we're doing. We're just multiplying. We're going to get prime coordinates. Here we go. Let's do another one. Let's go, I don't know, -1 and 4 with a scale factor of 1/2. Which means this point is going to get half. This point's going to get half as close. Okay? The distance is going to be half as far from its original. Okay? The image is going to be half as close, if that's a better way of saying that. So we're going to take half of -1 and half of 4. That's all we're doing. So 1/2 times -1 and 1/2 times 4. I have my x and I have my y. I actually think I like writing it better than this guy. This just looks a little weird to me. I'm going to do it this way. Okay, so it's half of 1 and then make it negative. So you should have -1/2. Okay, and then half of 4, 2. Ta-da! That's it. That's all we're doing. We're just multiplying each coordinate by our scale factor to get our prime coordinates. Let's go, I don't know, 1570. I don't know. Our scale factor is 2/5. Good thing I have this thing. Okay. So we're going to get closer to our center of dilation because our scale factor is less than 1, greater than 0, which means this point, the distance to this point is going to shrink. Okay. How much? 2/5. So we're going to multiply x. There we go. 2/5. I was looking at how I wrote it. Oh, you can't see that. Kind of sloppy. 2/5 times 15 and 2/5 times 70. Calculators are great things. Okay. So 2/5. If you don't have a calculator, you would multiply across top and bottom. You could throw 15 over 1. So you'd have 30 over 6, which is also known as 6. Okay. Or if you cross cancel, you go 5 goes into 5 one time, it goes into 15 3 times. So then you end up have 2 times 3 up top. So 6 is our new x coordinate. And now I want 2/5 of 70. All right, 2 times 70 is 140 over 5. How many times is 5 going 140? So let's go, that goes 228. I'm going to double check my math. 140 divided by 5. Ooh, very nice, air 5. There we go. So we have 228. There you go. That's all we're doing. Just multiplying our x and our y by our scale factor. Okay? That's example 1. Now example 2, I'm going to put 3 or 4 points together to create a figure and then do the work. I'm going to take baby steps on this dilating stuff on a coordinate plane because I got to make sure that you guys understand what's happening here. Okay? Okay, so we're going to dilate with the given scale factor, and I'm only going to do one of these. I'm going to let you guys go on this, and hopefully you guys will work together well and quietly. Yeah. Okay. Let's dilate pig. I like piggies, they're cute. Let's go. Okay, we're going to dilate pig with these points. So go ahead and hit pause. We're going to dilate pig with a scale factor of, what do you want to do? Do you want to get enlargement or shrink? I don't know. Let's go 3. Okay. So coming tomorrow, we would plot these points right here for our figure. Then we would know what triangle pig looks like. How do I know it's a triangle? Because there's 3 points. Okay. And then we're going to dilate with a scale factor of 3, which means pig, triangle pig, is going to get 3 times as large. It's going to get 3 times as far from the center of dilation. Okay. Here we go. Each x and each y has to get multiplied by 3. So when you have a figure to dilate, you actually have like 3 little problems in one. Yay, you! But it'll be good practice for tomorrow. So here we go. So this is going to be p prime. Okay, I'm going to organize these. So this gets multiplied by 3. That gets multiplied by 3. And this point gets multiplied by 3. So here we go. We have 3 times 2, and then we have 3 times 4. Okay. And then I'm going to go I prime. I'm going to make these i's. We have 3 times 0 and 3 times 6. So I'm just showing my scale factor getting multiplied by my x and y each time. And then let's do it for g. G prime. 3 times negative 2. And then 3 times 5. I put these guys in parentheses just as another way of showing multiplication. That's all. And the reason why I switched is because negative 2 is, it's negative, and so it would look like 3 minus 2. So that's why I put them in parentheses. These I just used a dot because none of them were decimals. That's the great thing about multiplication. There's many ways of showing it. So here we go. Your p prime coordinate. 3 times 2 is 6. 3 times 4 is 12. We multiply both of these by 3. We got it. Do you have to show this word, even though you could do it in your head? Yes, you do. You should know me better than that. All right, 3 times nothing. Nothing. 3 times 6. 18. And let's go G prime. 3 times negative 2 is negative 6. 3 times 5 is 15. There you go. You just dilated pig with this given scale factor of 3. Here are your prime coordinates. This is what we call prime coordinates right here. These are prime coordinates. Okay. So tomorrow, you're going to have to do all of this, plot the figure, and then create the image. Okay. So today, we are just multiplying. That's it. We're preparing to actually graph them, where you can see the triangles. Okay. There we go. I'm only going to do this one problem, because it's a lot of, like, I just did 3 more problems, but I just kind of put it together into a figure. That's all it is. Okay. It doesn't matter if you put your scale factor in front of K or after K. It does. I think I switched back and forth between the 2 different examples. It doesn't matter, because A times B is still B times A. So it doesn't matter which order. Okay? All right. When in doubt, ask someone next to you, or ask Miss Monica. She can help you on this. Okay? Have a great day. Be excellent to each other. Be kind. Stay off the naughty list. Sound good? All right, bye guys.